of velocity and acceleration of the object in motion along a straight line. There is one-dimensional motion. To study the motion of the object under constant acceleration. Here the object is going to move under gravity. Any object moving under gravity has a constant acceleration. Motion of object moving under gravity, you can take an example of uniformly accelerated motion or constantly accelerated motion. And you are going to calculate the velocity and acceleration of the object moving under gravity. So the velocity can be calculated by using this formula. Average velocity equal to delta x by delta t. Delta x is a displacement, the final position minus initial position divided by final time minus initial time. And this formula gives you the average velocity, and average acceleration can be calculated by the next formula, A equal to delta v by delta t. Delta v, final velocity minus initial velocity divided by final time minus initial time. Since the object is moving in a straight line, and I can use the three equations of motion, and the acceleration of the moving object is constant. For these are the two key points which allow me to use the three equations of motion. Let me use the three equations of motion. S is equal to V0t. Can I write, Shubham? Whose book is this?
Me.
Can I write?
Yes, yes.
Of at square. This object starts from the rest. So initial velocity equal to 0. See, the object is moving this x direction. Let us take this as delta x, displacement produced, is of a t square. Clear? Of a t square. From this, I can get the acceleration. Your acceleration is equal to 2 delta x by t square. Clear? By using this formula, I am going to calculate the acceleration of the object. And the acceleration of the object can be calculated by using this formula. What is this? If the object is moving under gravity, let me write this. If the object is moving under gravity, this is theta, this is mg, this is Fn, this is x direction. So this is theta. I can resolve this into two components. Mg cosine theta is acting here, mg sine theta is acting here. So since the object is moving, I can use the second equation of motion, Newton's second law of motion. Sigma fx is equal to ma. What is sigma fx? mg sine theta minus. Why minus? Is acting to the left. It's too much sweating, right? I don't know what to do. Is equal to m into minus a. Why minus a? The object moving to the left. Can I cancel minus m? Your a equal to g sine theta. This is another method of calculating your a. This is a theoretical calculation of a. G, you know, 9.8. Theta is the angle you can measure from this. So, experimentally I am going to calculate the acceleration of the moving object. This is a theoretical calculation. How to calculate experimentally? Let us come to this. This schedule I am going to fill. The change in the position delta x, the time taken t equal to tf minus ti, t square, average velocity delta x by delta t, acceleration a by t. How I am going to make the measurement? First I am going to fix the initial position. So initial position, I have to set this. So take this the time to get mode. Right? Press this button. You have to check the position of the gate is perfect or not. Yes. The light will work only when this screw is crossing this point. Other time, the light should not work. You have to adjust the position of these two in such a way that I am going to fix this at initial position. Mustara. Keep like this, and there is a line, right? These lines will coincide with each other. Right? Now this is at initial position. So let us take the distance travel. Shall we take 15 centimeter first? 15 centimeter, this is meter, right? 0.15 meter, 15 centimeter. So 15 centimeter, the distance travel should be 15 centimeter. It is 10, 30, 35. The gate number 2 should be at 35. Before fixing the gate position, let me check the height. So to check the height, put the gate. Shaking. Let me check the height of the gate. Gate number 1 I already checked. Gate number 2. Yes. The light is glowing only when this screw is moving. If it move here, it is not proper. Now the height of this is okay. I am going to fix the position at 15 centimeter from here. 15 means 35. Right? Done. The next is keep the car and bring it here and press the button, the yellow button. Now is working, right?
Yes.
Move slightly to the left. Press again. Now release this. Why I am doing this? When the screw touches the gate, the speed of that car equal to 0. That assumptions we made in reformatting the equation, right? Let me release this. This is the time taken to travel the distance, right? So time taken to travel the distance 15 centimeter. So whatever the time, just write it here. Square this t square. Alas? V equal to delta x by delta t. This is delta x, 0.15 divided by delta t. T, you will get this. Acceleration, v over t. This is v. This divided by this, you will get a. Alas? You are going to change the distance travel as this data will be printed on the question paper. So if it's 20, you should do 20. 30, you should do 30. Whatever the value printed, you have to use it. Suppose if you say 25 centimeter. So 25 centimeter should start from here. 10, 20, it should go to here, 25. 25 centimeter, this is up to 45 is coming, right? This is not good ruler. It is coming like this. Okay, the height of it. So let us check the height. It's not working. The height is too much. We have to reduce the height. So I can reduce the height. Let me check now. This is already fixed. No problem. See this one, when this part is coming, it's not working. Only screw comes, it is working, it is working. Now again, let us check the distance. It should be at 45. Now change it. See, it should be at 45. Now once I fix the distance, what I should do? Do this. Right, move little and again press this, release this. This is the time taken to travel the distance. Hello? Now complete the experiment for Shabab, you are doing the review. Complete the experiment for all the values, right? You are going to draw the graph between this is y-axis, this is x-axis. If you draw the graph, yes, this is delta x, meter, right? This is t square, second square is y-axis. You will get a straight line. So this is your x1, this is your y1. You know how to select all these things. This is y2. And the slope of, let me write here. The slope is equal to y2 minus y1, x2 minus x1. What's the unit of the slope? Meter over second square. You got the slope now.
Doctor, is the difference if I
Change. You have to change the unit.
delta x and delta
Yes. The meaning of the slope is delta x by t square. Look at here. A experimental equal to 2 into delta x by t square is equal to slope. A experiment is equal to 2 into slope. Something meter per second square is your A experimental. Clear? Now you got the acceleration of the object moving under gravity. And you have to write the source of error. What could be the mere source of error? There are 3 sources of error in this experiment. Number 1 is the delta x. The delta x is the distance traveled. Suppose if we say 15, you may fix a different value. So delta x, don't say delta x, is the distance traveled. And the second error is the time taken to travel the distance. The time taken, though you are using the device, and you may, some error might have occurred. And that could be the time, measurement of time taken to travel the distance, could be the other source of error. Another important source of error is the angle of inclination. This angle is also contributes to the error towards the calculation of A. Clear, Subha?
It should be 0, pi?
No,
5.
it's a 5 or more,
Yes.
That's it.
right? Yes, any other doubts, Subha?